Hello all. I'm recording this lecture video from my hotel room in New Orleans. So as you know already, I'm in New Orleans for today's lecture or for Tuesday's lecture, and so we'll do virtual lecture with this video. You're also going to have a virtual lab. It will all be posted on Canvas, and you can do the virtual lab from the comfort of your home as well. And then I'll see you again on Thursday of this week. And on Thursday this week, Marla, my girlfriend, who is the forensic drug chemist, is going to be coming to give you a talk about her experiences as a drug chemist. So, without further ado, let's go ahead and do this lecture, and then after you do this lecture, we can you can move on to working on the virtual lab. And then that lab is due, of course, as usual, a week from today, at the end of the day. Okay, so let's go ahead and get started. So today in this lecture, we're going to be talking about forensic toxicology. This has to do with things like alcohol mostly, alcohol. We'll talk about that. We'll talk about field sobriety tests and breath tests. How do we collect different toxicological samples? What actually is the role of a forensic toxicologist, and why is that different from drug chemistry? A lot of people confuse the two. And then we'll describe some analytical techniques, and then we'll talk about drugs and hair and drugs, and then we'll also talk about poisons, and then the significance of toxicological findings, and then also the DRE, which is the drug recognition program. So, what killed Napoleon? This is an interesting story. If you don't know who Napoleon is, he was like the emperor of France or something very long time ago, and he was able to conquer most of Europe. But then he was defeated at the Battle of Waterloo by the Duke of Buckingham, and then was like exiled to Malta. I can't remember, one of the small little islands off the coast of Europe. And while he was there, he died, and many believe that he was poisoned, but nobody knows how he was poisoned or what poison killed him. So you could consider him to be one of the very first toxicological cases. So that's kind of an interesting thing that's still a mystery today. So, what exactly is forensic toxicology? Well, different from drugs, because forensic toxicology normally is about fluids, tissues, and organs, unlike what drug chemistry is, because drug chemistry, you deal with the actual drug itself, like the marijuana, cocaine, or whatever, whereas toxicology is always going to be bodily fluids, tissues, and organs. But the most common, of course, is going to be bodily fluids like urine and blood, and testing them for poisons or drugs. And so that's the most common. But I have seen and heard of people, of forensic toxicologists taking body organs and tissues and extracting material from that to do analysis on. So, what's the toxicology of alcohol? Like we talked about before in the drug section, alcohol is a depressant, right? And it principally affects the central nervous system and the brain. And so, since alcohol is so prevalent in our society, it's probably what we would call we would say that it exemplifies the primary objective. It represents the primary objective of most forensic toxicology, and so its detection and its isolation is important because it's just so prevalent in our society. And we talked about it already in the drug section, but it's a colorless liquid, right? And it acts as a drug because it depresses your central nervous system, and so your blood alcohol concentration is directly proportional to the concentration of alcohol in your brain. All right, so alcohol absorption. So what is alcohol absorption? That's basically the amount of alcohol that you can absorb over time. And you see in the chart here that based on how much food you have in your stomach, and how much alcohol you've consumed, uh, you can get much more intoxicated and much more under the influence of alcohol drinking on an empty stomach. Uh, you see there with a meal of potatoes after after about 3 hours, or maybe it's even 2 hours, you really do kind of max out your alcohol absorption in your body to only about 0.05, right? Whereas on an empty stomach, you can get all the way up to point 0.1. Point 0.1. So the that's why they always say it's a good thing to eat and not be drinking on an empty stomach, right? So the interesting thing about that is in the blood, alcohol will appear in minutes after you're drinking it, and so usually you eat food and you drink food and it goes through your digestive system and stuff like that, but alcohol can get absorbed very quickly, and so alcohol is then entirely absorbed into the bloodstream within 30 minutes to 90 minutes after completion of the drinking. And then it can be there and be affecting you for hours afterwards. And so it also depends on that type of alcohol you're drinking too. Beer is definitely absorbed more slowly than like alcohol, than like 80 proof or more alcohols like vodka or um, vodka or tequila or whiskey, and that's because beer has carbohydrates in it, right? And so the carbohydrates actually act like potatoes that you would drink. You're basically drinking a meal of potatoes, and when you're drinking beer, so it definitely absorbs slower. And so, drinking beer will get you intoxicated slower than drinking, alcohol, the straight up alcohol. So, the what I'm showing you here is that when a male drinks, like say a beer, about 2/3 of which of your body volume is water, right? And so compare that with a female where it's only 50% water, and so drinking beer or just drinking a beer will affect a woman faster than it will affect a man. And so that's really what I'm trying to show you with this here. So if blood is not available with other watery portions, the brain's cerebrospinal fluid or vitreous humor, it can be determined. It can be used to determine alcohol levels, right? So you can just see that the concentration of alcohol will be higher in a male. The concentration of alcohol will be higher in a female than it is in a male with the same volume consumed, because females have less water available to mix with the alcohol. So how does the body eliminate alcohol? Usually through oxidation and excretion, right? So if you follow the little path I have up there, you can see that alcohol is you swallow it, of course, and it goes in your stomach, and most of it, a lot of it gets absorbed in your stomach, about 20% of it. But then it passes through your small intestine, and after it passes through your small intestine, that's where most of it gets absorbed and goes straight into your bloodstream. And so when it gets into your bloodstream, that's when it gets circulated through your body, including up into your brain, and so up into your brain, and so that's why it affects you so much, right? And then so if you ever notice, like sometimes when you drink, you can sweat and you can breathe out, and it will smell like alcohol, and that's because the alcohol has gone through all your blood system and has permeated through all your blood system, and so that's why you feel like you're sweating out alcohol and you're like even breathing out alcohol. That's how breathalyzers will even work. Before it even gets into your bloodstream, though, it goes through the liver, of course, because the liver secretes enzymes that will break down alcohol and turn it into acetaldehyde, and a lot of it actually gets excreted out, and you pee it out. But the part that doesn't get excreted out is what goes straight into your bloodstream, and that's what really affects your blood alcohol level. And so different races have different activities when it comes to the enzymes that are in the liver that will break them down. It's called alcohol dehydrogenase. And so if you've noticed that, Asian people, for example, will get more intoxicated faster than other races, because their alcohol dehydrogenase is so like limited compared to the other races. And it's much more complicated than what I'm saying. It's basically, but I'm giving kind of a basic overview. but Asian people have less active that enzyme, alcohol dehydrogenase, and so the alcohol doesn't get broken down as much and goes into the blood and then affects the rest of our bloodstream and our bodies faster, our brains faster than most other races. Whereas most other races have very active alcohol dehydrogenases, so it will take them a little bit longer to get intoxicated, and so and in that time, more of it will get peed out, through excretion, and so that's why most of the time when you go out to drink or something with an Asian person, they're very cheap dates, right? Because they they don't require as much alcohol to get to that buzzed feeling, and so yeah. And then again, most of it gets peed out. You excrete out when you go pee. But yeah, so the elimination or the burn off rate of alcohol varies, but it's about 0.15% per hour. It's a good average. So if you have a blood alcohol level that is 10%, then it's going to take you about 6.5 hours to actually make it come down to zero or make you completely sober again. And we'll talk more about what blood alcohol level is in a second. Oh, we're talking about it now. So blood alcohol level concentration, or the BAC. Most people know this is what they use to determine whether or not you're intoxicated while you're drinking or under the influence, right? And so in most states, the blood alcohol level of 0.08% is considered intoxicated. And so 0.08%, and so what that translates to is really 0.08 grams of alcohol per 100 milliliters of blood, right? So another way of expressing that is 80 milligrams per deciliter of blood. So, but everybody just remembers 0.08. That's the legal limit, right? So you can see here on this chart that different BACs actually correspond to different levels of being intoxicated or even in medical danger. And so if you take a look at it at 0.08 at the legal limit here, it's going to be 0.08, so as you can see, 0.08 here with the legal limit is pretending. As you can see here with this table here, the legal limit of 0.08, depending on what your weight is, it tells you what level of intoxication you're at. So I'm about 220 pounds right now, and so 0.08 for me is like right around here. I'm sorry, I don't have a pointer. Oh, I guess I can use my mouse. It's right around here or so, right? So even at 220, I'm going to be drunk at 0.08, right? And so the less you weigh, right? The less you weigh, the faster your blood alcohol level will increase to 0.08. And then so you can see down here, this is dangerously, or down here, these are dangerous alcohol levels right here. 0.17, 0.19, all those are very dangerous. And then you get to down here where it's like in the 0.3s, and once you're in the 0.3s, that's like medical emergency. And what that means is that you are in danger of alcohol toxicity, or what is called alcohol poisoning. So you never want to ever get down to that level. So I talked about this I already talked about this a second ago, but I wanted to just kind of reiterate that alcohol will enter your bloodstream or your circulatory system, as it's 80% of it is from the small intestine. And again, the liver does excrete a lot of stuff, a lot of enzymes to break it down and stuff. But once it's exhausted its supply of enzymes to break down your alcohol, it'll go straight into your bloodstream. And so you can see that the path that it takes, right? Our bloodstream, of course, our circulatory system is closed, and we have a system of veins and arteries. Arteries generally take blood away from the heart, whereas veins take blood back to the heart. And so from the stomach to the small intestine, right here, we would be the body tissues, but primarily we'll just pretend that that's where the small intestines and the stomach are, where your alcohol is being absorbed. you can see that once it gets absorbed, it goes into the body tissues, right? And it goes, and then the body tissues takes the alcohol through a vein back to the heart. And so this is the heart right here. This is the right atrium of the heart. The right atrium, and then pumps the blood that has alcohol in it into the right ventricle, and then the right ventricle pumps that blood into the lungs. And so that's where you breathe in and breathe out breathe out oxygen. Sorry, breathe in oxygen and breathe out carbon dioxide. And then so from the lungs, it moves into the pulmonary vein, and the pulmonary vein takes the blood back into the heart to the left atrium, and the left atrium pumps that blood into the left ventricle, and then the left ventricle will pump that blood to the rest of the body. And so now it's going through the rest of the body, and this will include your brain and everything else where it makes you intoxicated. It's up here in the lungs, right, where you can do a breathalyzer, and then you can take you can do a breathalyzer, and they will detect alcohol in you, and there's really nothing you can do about it because it's not coming from your actual breath. It's actually coming from your blood that we detect alcohol in a breathalyzer test, right? And so doing things like chewing gum or having, I think I saw a hack once that they said throw pennies in your mouth or something that will mess up the breathalyzer. None of that stuff really works. Really, the only thing that works to mess up a breathalyzer is time. The longer you wait before you drive or take a breathalyzer, the lower your blood alcohol level after you drink. And so, oftentimes it's delaying. You have to delay the breathalyzer or whatever the blood test is. Sometimes people can even respectfully request not to be breathalyzed. Let's say you're driving and you're under the influence, or maybe you're not even under the influence, but you had a couple of drinks, and and they pull you over and they suspect you of alcohol intoxication or DUI or whatever. And sometimes you can even, I'm not saying this always works, but you can respectfully ask that to be because the law says you just have to blood test it. It doesn't say that you have to be blood tested with a breathalyzer. So you could ask for a blood test instead of a breathalyzer, and generally what happens is that they'll have to take you back to the station. It'll take a few hours for them to get you all get you all like set up, and then what is it called? What do they call it? I can't remember now. But they'll, to get you input into the system. I don't know. I don't remember what the phrase is. But, and then finally they can actually get you to get the blood test. And by that time, maybe your blood alcohol level's gone down enough that's not above the legal limit anymore. And so that's a strategy you can use. You can try. I'm not saying it's going to work every time, but you can definitely ask to be blood tested instead of you being done, instead of having a breathalyzer done. So. This, and I was saying a second ago, I already said this in the previous slide, but the reason why breathalyzers even work is because your lungs, when the blood gets pumped back into your lungs, it's actually already been the blood's already absorbed alcohol, and so it goes back into your lungs, and in your lungs you have these little things here called alveoli, where the oxygen and the carbon dioxide exchange occur. And so that's inside your lungs, right? And so wherever you are, whenever you're breathing, right, you are breathing in and out gases, and part of the gases that you breathe out, because there's alcohol in the blood, is alcohol, and that's how a breathalyzer works, right? So again, blood goes into the lungs and into the alveoli to get oxygenated, and then goes out of the lungs to provide oxygen to the rest of the body. And if it just so happens that the blood that's going to the lungs is saturated with alcohol, then it will definitely be breathing out alcohol along with carbon dioxide. And so that's how a breathalyzer really works. So how does a breath tester or a breathalyzer even work? This is actually an old picture of a breathalyzer. I've seen newer ones. That's actually kind of a big one. They have pocket ones now too. If you ever get taken back to the station to get breathalyzed, that's usually what they'll work on. They'll use on you instead of using the handheld one, because those ones are a little bit more accurate. But what happens is that in the breathalyzer, there's this there's an infrared light, right? And then you breathe in, and then your breath is inside of this chamber, and then the infrared light goes through, and whatever. Sometimes, it's not sometimes, but if there's alcohol in your system, the infrared light will get absorbed, and some of it will get transmitted through. And when it gets transmitted through, some of the light gets transmitted through. Alcohol is a very specific like transmittance kind of spectrum. They call it a spectrum, or even they call it an hour spectrum. It's different from every other gas, especially carbon dioxide and oxygen, and so they can use that to quantify using the detector how much alcohol you have in your system. And so this guy here just blew a 0.167. Good God, how's that guy not dead? I don't know. Like I've never seen anybody be over. In my experience, I've never seen anyone over actually the legal limit. Most of the time, I see them very close to the legal limit, but never up to or even past the legal limit. And so, uh, but yes, that's usually how the older versions or the ones that are at stations do test your alcohol. And again, the other way you can do it too is with a blood test. So here's a picture of the actual handheld breathalyzer. So this is all a part of like field sobriety test. The handheld breathalyzer is a sobriety test, and then also they'll do the whole eye thing. All right, they call it the horizontal gaze, the nystagmus test. Sorry, I can't say the word nystagmus test. And so they'll tell you to walk and turn, and then and then the one leg stand. They're all considered they're all considered reliable psychophysiological tests. You can also use a breathalyzer, right? And then, but interestingly enough, like these things aren't even admissible in court. They're just used as a kind of a presumptive test for you out in the field, and then they have to take you back and get you actually tested. So the eye testing, that's where they make you like look at a pen, and then they watch your eye movement as you move your pen back, and they move their pen back and forth. And if your eyes are moving very jumpy and they're not smooth looking, then that's also a sign of intoxication. So, how do they do blood testing for alcohol? Because we just talked about breath testing, but how do they do blood testing? Usually, it's with grass. It's usually with gas chromatography. And we talked about gas chromatography while we were in the drug section already, but it's that big machine that I call the reverse blender, right? And so what it does is that it will actually go into the GCMS. They'll do a sample prep and put your blood, not directly, but after a sample prep onto the GCMS, and they will actually measure the conversion of alcohol to acetaldehyde by alcohol dehydrogenase, right? Which is that enzyme I told you that Asian people don't have much of, right? And that's why it's very difficult for an Asian person to reach, well, it's very easy for them to get intoxicated, but it's difficult for them to get to reach to the actual legal limit, because our alcohol dehydrogenase is so inactive that it just gets like eliminated very fast. And so that conversion is what we detect. So we detect actually acetaldehyde in the GCMS, right? And so that's kind of a picture that you see there of ethanol right there in a blood sample. But that's how blood tests that's how they test your blood for alcohol. They use a big instrument, the GCMS, the same thing that we use in the drug lab to test drugs to see if they have drug content in them. And I've shown you a picture of those before, and we have one in the lab. How do we collect and preserve blood? Most people know this already, because it's the same thing that they do when you're at the doctor's office getting a blood test, right? And so these things are vials that are vacuum sealed, and so when you puncture them with a needle, like when you get like a little phlebotomist gets blood from you, the vacuum sucks blood out of your blood vessels, and that's why you feel, or you don't feel, but you see the blood kind of shooting into into the tube. It usually contains this thing called an anticoagulant and a preservative. The anticoagulant is heparin. It keeps it from clumping up. blood, when it gets exposed to the air, will start clumping up, and so heparin will stop it from doing that. And then you can put it into the refrigerator, and preserve it in the refrigerator, and then test it later using the GCMS, like I said. Sometimes they also test it with the LCMS as well. So GC is, of course, stands for gas chromatography. LC stands for liquid chromatography. They use both in the lab. But again, I don't want to go into too much detail about that. It's not a forensic chemistry class. So I'm just giving you kind of a brief overview of that. So let's see here. If you don't do a good job of preserving these things, a good job of preserving these things, you run the risk of actually degrading the sample. So that's why they've got to do a pretty good job of collecting these samples and putting them in the correct vials with the right kind of stuff to preserve it and stuff like that. And I don't know if I've told you this before, but I remember this case a little while ago where this guy was, I guess, passed out in the hospital, and the police were like, it's kind of like insisting that a nurse take his blood, and she refused because, well, if you're unconscious and they don't have a warrant, they can't take your blood. The police can't take your blood. That's actually assault. And so she fought and she fought, and she would not allow the police to take his blood. And the police, for some reason, wouldn't just go get a warrant. And so they ended up arresting her or something like that, right? But in the hospital, I don't remember what the hospital did, but it was crazy. But yeah, you're not supposed to be able to. The police are not supposed to be able to take your blood while you're unconscious without giving consent, right? You have to give consent for blood unless there's a warrant, right? So that was an interesting story. I forgot to look it up to get the details, but you can look it up if you want to. So alcohol in the law, like I said before, 0.08 is the legal limit. All right, and so this chart on the right here just kind of shows the percentage of chances of the chances that you would get into an accident based on your blood alcohol level. And so it's virtually nil, zero, if you're only at a 0.04. So if you're at a 0.04, you're like, that's like almost nothing. Right, and so I mean that's basically a couple beers or something like that, and most people are not intoxicated at 0.04. But once you get to 0.08, the chances that you're getting into an accident is about 4 times as much. And if you're at 0.16, you're about a 25% chance of getting into a car accident, right? And so the interesting thing about that is, I mean, like I said before, at a 0.16, I don't even know how you're driving. I don't even know how you're like walking around. So I would be more concerned, like at the earlier ones, like I get in at 0.08. That's where I would definitely make it so that you would make sure that you are not at a 0.08 or higher, right? But all the way up to 0.16, that's crazy. So in most law enforcement agencies, including my own, the division or the unit or section that actually does blood alcohol testing, like breathalyzers and stuff like that, is called implied consent. And the reason why it's called implied consent is because when you sign a little piece of paper for you to be able to drive on public streets and highways, you've already consented to a blood alcohol test, right? And if you don't, then you will lose your license. And so that's the reason why, since you were, just by the fact of you driving a car, you can be stopped to be asked to be alcohol tested. And again, you don't have to have the blood alcohol test. You don't have to have a blood alcohol test using a breathalyzer, right? Or even the sobriety test. You can ask them to do a blood test, and usually it takes more time to do a little bit more time to do a blood test. So it'll give you some time for your alcohol level to go down, your BAC level to go down a little bit. But whatever way it is, the state still, just by the mere fact of you driving a vehicle, the state still has the right to if you're actually driving the vehicle, right, and they pull you over, they have the right to blood test you. Not blood test you, but alcohol test you. So alcohol in the Supreme Court. So I can never say this word. Is it in Schimmer versus California in 1966? The Supreme Court ruled that the taking of blood samples was not protected by the Fifth Amendment. But then, in 2013, the Supreme Court in Missouri versus McNeely ruled that the police should obtain a search warrant prior to drawing a person's blood for blood alcohol test. And so this was the whole case I was talking about before, where a police officer was trying to get blood from a supposedly intoxicated person that was passed out, and and at a hospital, and they didn't have a warrant, and so the nurse, knowing this law, refused to take the blood for refused to draw the blood for the police officer, and it got very, very high tense, very tense, and um, situation, and I think the nurse even got like arrested for it and stuff. It was kind of a bad situation, and I don't remember if the hospital like supported her or something like that, but she knew that that you can't take a person's blood without a search warrant, and so you can always give your blood, and give a voluntary blood test, and that's what you should do instead of just doing a breath alcohol test. But if you're unconscious, then they need to have a search warrant to take your blood. So the chart down here just kind of tells you what your blood alcohol level is after drinking certain things. So it goes body weight and then ounces of alcohol, 80 proof liquor, and then the maximum blood alcohol concentration. And you can see here, like, you can use this to kind of figure out how many drinks you can have before you get to a certain alcohol level. So I'm 220 right here, right? And if I want to drink, say, let me have a night where I'm doing 5 shots, and it's easier if you have a line. So I can't draw a line because I'm not out there with you there. But if I draw the line just kind of virtually at 220, to get a .08, four or five shots will get me to a .08. Although I've never gotten to a .08 before, so because I have been breath tested, but that's also on an empty stomach. I never drink on an empty stomach. I always drink on a full stomach. So using a full stomach, you can see here 220, which is right over here. 220 is right there, and then you can't see me drawing the line, but 220, I can get like 9 shots in before I get to a .08, right? So it's always better to drink on a full stomach if you're not trying to get like super intoxicated. So you can use this chart too. You guys going out or whatever, you can use this chart and you can kind of figure out, how much, based on your weight, how much alcohol you can have before you get to a certain alcohol level. So you just want to be below the legal limit every single time. Just use the chart, right? So what is the role of the forensic toxicologist? This is Alexander Gertler. I think I've mentioned him before. He's like the very first toxicologist, forensic toxicologist from New York. He was the guy that helped in the Francesco something case. I can't remember the last name now, where the lady got cut in half. It was like the first case I told you guys about, where the lady got cut in half and he got caught putting her half of her body into the river. But anyway, so he was the one that actually determined specifically that the woman was poison, carbon monoxide poison, right, from the gas going out. Even though the ME had already determined that this woman had died from carbon monoxide poisoning from her pink skin, it had still to be confirmed by the forensic toxicologist, and Alexander Gertler was the one to do that. And so that should tell you then that the role of the forensic toxicologist is to examine body fluids and organs for the presence of drugs and poisons. All right, and oftentimes, if the person is dead, it happens after the person's dead. And I think I told you that before. My father-in-law, Marla's father, he had died from like an aneurysm or something like that. It was a hepatic aneurysm, embolism, something like that. I can't remember what it was, but the reason why it took like 3 months before we could get his death certificate, because the forensic toxicologist part was the part that took the longest to do. They do like I said before, they do autopsies like as soon as the body comes in, but the thing that takes the longest time is the forensic toxicology stuff test to see if there's any poisons or drugs in their system. And so the way Alexander Gertler did it was he actually went through and he took like stomach contents and lung contents and all that stuff of that lady, ground them all up in a blender, and then tested them for carbon monoxide and found that she was poison with carbon monoxide. So again, that's the difference between the toxicologist and the drug chemist, right? Drug chemists just deal with just the drug itself, whereas forensic toxicologists deal with body fluids to determine if there are organs to determine if poisons or drugs are present. So this is just a slide that kind of gives you the summary of what the difference is between drug chemistry and forensic toxicology. Toxicologists do not deal with drugs at the concentration levels that are found in powders and pills, since they are often consumed and have been dissipated and distributed throughout the body. So those concentrations in the body, are in the blood or the urine or whatever, are much lower than they are in the actual drug itself, which is what drug chemists do. The body is also an active chemistry laboratory. So as few substances enter, they completely leave the body. Few substances actually leave the body in the same state they did when they came into the body. When they came into the body. So they get, because they get metabolized. Drugs will get metabolized in the body into different molecules, and so again, forensic toxicologists have to make sure that when they're doing these tests, they're not just testing for the drug as it is before it enters the body. They also have to make sure they have to test those metabolites as well. And then lastly, when and if a toxicologist surmounted all these obstacles, he or she must prepare to assess the toxicity of the drug or poison. So they have to, not only do they have to figure out if its presence, right, they also have to figure out whether or not the amount present was actually toxic or not, right? So what are some techniques that we use in forensic toxicology to to extract these drugs or these poisons out of the blood or the urine? Probably the most common thing is this thing called the extraction, right? Using a separatory funnel, and so you put a solution in there into the separatory funnel, and then you put that solution, or that sample rather. You put a sample or something into the separatory funnel that has your molecule of interest in it, whatever the drug molecule or poison is, right? But you don't want it to be in that, because it's like blood or something. You can't just put blood onto an instrument, onto a GCMS. And so you put on a solvent layer, right? So the solvent that's separate from, that's different from water, because blood is mostly made of water. So anything that will not dissolve in water, they'll try. So things like ethyl acetate or something like that. And a lot of these drug molecules will be solvent will be soluble in that other layer, right? And so there's two layers sitting on top. It's kind of like oil and water, and the oil layer is sitting on top of the water layer. And what you do is you shake it up, and then when you shake it up, the molecules that are in the blood layer will go into the layer that is the what we would call the organic layer. You can retrieve some of that using a pipetter, right? And put that test that on the LCMS or the GCMS. You don't want to put just straight up blood onto the LCMS or the GCMS, right? So a lot of drugs will actually be considered acids or bases, and so an acid is capable of donating hydrogen ions, and you don't need to really know that, but that's what an acid is. A base will accept one, and so I don't remember if I talked to you about the. I did talk to you about crack cocaine. Crack cocaine is, they have the kind of the crack cocaine that's the cheaper version of the cocaine, like the white powder cocaine that's super pure and stuff. And so that's the difference between the acid version of a drug and the basic version. The crack cocaine is also known as cocaine hydrochloride, whereas cocaine is just cocaine. And so that's basically the difference there. And then using the different how acidic a drug is will tell you whether or not it's basic or acidic. And so that's on the pH scale. And the pH scale is from 0 to 14. And so at 7, the solution is neutral, but if it's below 7, it's acidic, and if it's above 7, it's basic, right? So you can also use those properties as well to do an extraction. And with this, the analytical scheme here is almost exactly the same as it is in drug chemistry. We always do a screening or a presumptive test first, and then we do a confirmation test, right? And so screening tests, can be just regular old so the sample, if you have to always go through sample prep first, right? So you extract the drug, with the appropriate pH, whether it's an acidic drug or a basic drug, and you screen it using either a regular immunoassay. We talked about what immunoassays are in the drug chemistry section. A gas layer chromatography, a gas chromatography or a thin layer chromatography. We talked about those as well, and the drug chemistry. You'll see these in the examples of these in the lab. But then also, after we get that, then we use gas chromatography and mass spectrometry to actually do the confirmation test. And the gas chromatography and mass spectrometry one is the one where we see those peaks that will tell you the molecular molecule. The molecule's like fingerprint, because every molecule has a different mass spectrum. And so that will be the confirmation test. So it's always a screening test first, and then it's going to be a confirmation test after that. So this is actually thin layer chromatography right here. What you see, and I showed you this already in the what's it called? The drug chemistry section. When we talked about that, right? You put a drop of something down there, you put it into some solvent like this, and then what's in it will spread out. And then when you spread out, I think this is actually this. I recall that this is the TLC of like was it of marijuana, like maybe THC or something like that, like our CBD oil. But anyway, different molecules, drug molecules, will separate differently, and so you can kind of estimate how far a molecule has traveled from its origin point, and that can be a presumptive test or a presumptive test or a screening test. That's what I was trying to say, a screening test. But you're still not really super sure that it's there, so you still need to go to confirmation test. Another way to do it too is with a gas chromatograph. Here, there's not a mass spec here. It's just a chromatograph, and you get this one little peak here that tells you, okay, I know that cocaine usually has this peak right here, but it might not always be cocaine, right? So these are both still screening tests or presumptive tests. But then for the confirmation step, you have to take it to a mass spectrometer, right? And so the mass spectrometer is this thing here, and it's the thing that actually, after the gas chromatograph, acts like the reverse blender, not breaking, but separating out a mixture, the reverse blender, gives you the chromatogram. Then each one of these peaks will go into this thing called a mass spectrometer, and then the mass spectrometer will give you the mass of each of those peaks, right? And so it also gives you this pattern. They call it a fragmentation pattern, and that's basically the fingerprint of a molecule. And so if you have a fingerprint of, for example, cocaine, then you know that cocaine is present in the sample, and that's going to be your confirmation test that there was cocaine in the sample or something like that. So it's literally the same thing that they do in drug chemistry. You can also detect detect drugs in hair as well. In fact, drugs, they inhere much longer than it does in the body. So if you want to see if someone has, assuming they haven't cut their hair recently, if you want to see if someone has been doing drugs in the past, few months, you can, as for, because they have long hair, right? If they have really long hair, then you can test it by test their hair as well. So I think there's like even commercial companies for parents who are like freaked out about their kids doing drugs, and they'll send them their hair in to get it tested. And so, but yeah, the reason why this works is because your hair actually has blood, has capillaries from your arteries and your veins, going into it, and so the drug molecules will go into your hair and they'll get permanently trapped there. And so hair will definitely have drug in it if you have been doing drugs. And human hair only grows like 1 centimeter per month. And so if this person has like really long hair, you can go back months, right, to see if they've done any drugs. It's permanently trapped there. There are trace amounts of drugs trapped in that hair for a long time, unless they get it cut off. We can also detect non-drug poisons too. So on the left here, you see a picture of things like heavy metal poisoning, like mercury, antimony, arsenic. Is arsenic a metal? I don't think arsenic is a metal. Bismuth is a metal. Copper, you can detect that kind of thing. Is arsenic a metal? I guess it is a metal. I think it actually sits on the metalloid line. That's what it is. That's why I get confused with that one. But anyway, carbon monoxide too. We talked about Alexander Gertler and carbon monoxide. You can see how this patient here has a whole bunch of pink on their skin. That's definitely carbon monoxide poisoning, and then also the pink organs too, right? There, this person had carbon monoxide poisoning. So you can definitely tell from different things. Now you have to test them that this person, but you still have to have a confirmation test. Oh, I think this was the guy. Oh yeah, was this the guy that a few years ago? I believe I was actually in Germany when this happened, but a few years ago, yeah, 2016, he he might have been the one that was like on, was it bath salts or crystal meth or something? But he acted like a zombie or something, and he like chewed off someone's face like during a fight or something like that in Florida. Craziest things happen in Florida. I think that's what that was this guy. If I'm not right about that, tell me in the comments because I can't remember, but I'm pretty sure that that is this guy, who was the one that was like he attacked some individual and like ate off his face because he was like under the influence of either bath salts or something like that. Um, bath salts are bath salts um, or crystal meth. It could have. I'm pretty sure it was bath salts maybe. Uh, hmm. No, I can't remember. Someone look it up and see if I'm right and tell me in the comments because this is going to be a YouTube video anyway. Okay, so the part of the toxicologist's job is to be able to give an opinion on how the drug affects an individual, right? And so for this particular guy, it really affected the individual. He acted nuts, right, eating off someone's face like a zombie. And so, for many drugs, and blood concentration levels are readily determined, can be used to estimate the pharmacological effects on the individual. And so, a concentration of drug in the urine is a poor indicator of how intensely an individual is influenced by the drug itself. Because, again, before, a lot of the drug stuff, a lot of the drugs or even the poisons, they get changed and they get metabolized in the body before they get excreted, right? And so things that you have to consider is that people who are always on drugs or they've been exposed to drugs a lot, they have a higher tolerance for different drugs, right? So you can no, it's not a one size fits all kind of thing. So you kind of have to do your best when you give your opinion about how a drug should affect somebody. And again, this guy's affected. It affected this guy really bad. But most of the time, it affects individuals' behavior or motor skills, and it definitely affected this guy's behavior because whatever he was on, again, I think it was bath salts. Does it say on there on that toxicology report? Liquid sample, urine sample, rubber suction tube. That's blood. Medical records. Yeah, it doesn't say exactly what it was, but I'm pretty sure it was bath salts, and those bath salts really messed with that guy's behavior. And then lastly, this is the drug recognition expert or the program that they use to to evaluate if a person actually is on drugs. And so this was it was developed in the LAPD at the LAPD for a long time ago, and it was used to train officers to identify and differentiate between the different types of drug impairment. So this is there's also obviously this one has a state seal, Texas. So we have one of these in Texas as well. Not everybody's actually in the program and has been trained to do this, but we do have some, right? The program actually has standardized methods like blood pressure, pulse, pupil size, and other things that will help you determine what kind of drug impairment a person has if they are if they are drug impaired, and then. Even though a drug expert is on scene and is like determines something, you still have to have a forensic toxicologist there, not there at the scene, but have a forensic toxicologist test the blood or test or whatever in the crime lab to actually as a confirmation test. So even the DRE is like a presumptive kind of thing, and then you still have to have a confirmation test done by a forensic toxicologist that uses instruments like the GCMS or the gas chromatograph, mass spectrometer. That ends today's lecture. So now you should be able to do all these things, and then you don't have to, but you can go straight into doing the virtual lab if you want now. And so the virtual lab today will be about drug chemistry and toxicology. We have provided for you, and it's on Canvas already, the instructions for the lab, and then also the instructions for the lab and the pictures that you were supposed to take yourself in the lab to answer and to determine the different types of drugs that are present, right? So all you have to do in the lab is read the instructions in the lab report, I'm sorry, in the lab handout, and then use the pictures that we provide you to answer the questions. You don't have to actually do anything since it's virtual. If you have any questions, just let me know. I'll be back on Thursday. We can talk about it on Thursday if you want. But you can go ahead and start doing that virtual lab now, or you can wait. It's not due until the week after, same day, right? Tuesday the week after. Anyway, have a good day, and I will see you guys on Thursday.